Hello, my name is Michael Tinker. I'm a software developer with HibernateWithDatacom, and in the next few minutes I'm going to introduce the Hibernate library as a way to streamline data access for Java developers who are building Datacom apps. The background is a fundamental problem that comes up when developing applications against relational databases. There's often some kind of mismatch between the data model in a language and then the database schema in the database. So Hibernate's a popular open source solution to standardize object relational mapping in Java, and we're going to see that Datacom is easily integrated with Hibernate. This means that Java programmers can take existing Hibernate skills and transfer them to building Datacom apps with no special Datacom expertise needed. To give a little more detail on the object relational problem, in Java, the language constructs for data are called objects, and developers want to manipulate data through the methods of these objects. This kind of interaction is the most fluent and natural idiom for them to be productive in. But when building an enterprise application, typically we do need some kind of database that would give us good things like ACID transactions and so forth. This is wonderful, but does present programmers with a problem of mapping between the database schema and then the objects in the Java application. This is called the object relational mapping problem. So you can solve it sort of directly with JDBC because relational databases will seek some dialect of SQL. Then the developers can issue SQL from within a Java program through the JDBC API. The JDBC will return sort of raw bytes as data with a description through the relational schema of the semantics of that data, and then developers can do kind of a one-off solution where they get data using SQL over JDBC, comes back, they can then interpret that with some ad hoc coding as a plain old Java object, which is now the right place to do business logic. If we need to update the database, we retrace our steps and go back and change it through the same process. This can, if done carefully, work all right, but every time the database schema changes, you will have to rewrite potentially some of this code, which then has to be debugged and verified again. A second problem, which is not quite as serious but still significant, is that when you embed SQL in a Java program, because every database has a slightly different dialect of SQL, you're now locking yourself into that data source, so a database migration is going to also mean rewriting code. In short, these are just the kind of issues that do come up when there's some interface in the app stack that is not standardized. So the open source community has stepped in to fill this standards vacuum with the Hibernate project, and this is a library that solves the object relational mapping problem in Java. From the developer's perspective, a couple of good things happen. First, we get rid of the database-specific SQL dialect and use a standardized Hibernate query language. Even better, we're no longer sort of getting raw bytes back from the database and then applying a schema to get meaning to them. We directly manipulate POJOs in database transactions. And getting down the weeds for just a second, a developer would notice in this kind of code snippet that what would typically be an SQL query is now a fragment of HQL. We're getting back from the query a list of Java objects, and then we can interact with those objects directly by calling their methods. This is exactly what we want. The architecture of Hibernate is sort of what you would expect. It sits between the client code that the developer builds and then the database. Hibernate does use JDBC, so it requires a certain amount of configuration. It needs to know the JDBC driver for your database, and it also needs a sort of dialect class that allows it to understand any idiosyncrasies of the SQL that the database speaks. For each table you want to use in the database, you need a mapping XML file that describes the schema of that table. But the point is, developers get to interact with POJOs, and it's going to be significantly easier to just update these XML files as our database evolves instead of rewriting code. Can you do this with Datacom? Definitely. server provides a JDBC interface to Datacom, so with the JDBC driver for Datacom and a Hibernate dialect, which we have a beta version of as a Maven package jar, you can jump right in. A developer would recognize these coordinates as the way to import the dialect into a Maven project. And then the XML configuration is just a couple of lines. You just tell Hibernate that you have a Datacom JDBC driver here and a Datacom dialect. An example of what you might do is perhaps you want to get information from the must active task dynamic system table. So this is a Datacom table that provides task statuses. You build out a little XML configuration for the table. Here we have the name of a Java class that will be instantiated as objects that can be manipulated directly, and it's going to be mapped through Hibernate to the sysatom must active task table. Here we've got a bunch of different properties that specify columns being mapped to different fields in the object. And with that little bit of configuration in hand, any developer who has Hibernate experience can get started building an application that, say, monitors must, and we have a little example that does exactly that available to anyone who is interested. So this concludes our look at Hibernate, and I hope that it's easy to see how this kind of tool can make Java expertise translate to Datacom very easily. Thank you.